Hello everyone. We'd like to present our research on plant engineer performance improvement for effective risk reduction. Every engineer knows well and always consider about the local optimization would make the entire worst of the system, and therefore understand the importance of the risk management concept that well-balanced design and operations are required. Even the total safety has assured to make safety design by defense in depth concept, and the operational problems would occur in the future in the chain of fallacy of defense in depth in safety culture degradation. When organization accident finally happens, the risk management in the huge and complex system must be most important thing, which is an active improve the safety by balancing the system with efficiency of design operations. The contents of this presentation is here, starting with the explanation of risk reduction activity step, and after that I will explain effective risk reduction activities in the planning phase, risk reduction measures, relationship between human factors and human performance improvement, and conclusions. The risk reduction activity step has four contents. The first is the system design phase. In the initial design stage, global optimization is required through risk management. And this management includes the safety concept built into the system design, such as depends in depth or quality assurance. And next, three steps are placed in human performance improvement activities in the operations stage, namely, in the planning phase of the operations stage, the risk analysis and the preventive measures are installed, such as organizational and environmental design. Hazard elimination or substitution and barrier installation are included in the organizational and environmental design. But the hazard elimination or substitution is most important for the organizational and environmental design. As for runtime, effective use of human performance improvement tools such as peer check, flagging, task preview, or place keeping, etc. are recommended. And even these steps need to be implemented when the problems would occur. In addition, cause analysis and risk reduction measures must be implemented, such as time series analysis, 5 whys, or M-sures, and so on. In addition, the problems are fed back to the planning phase. For effective risk reduction activities, please refer to the risk matrix to be used as shown in this table. We show the concept of the risk matrix on this slide. Risk matrix are used for risk assessment for risk reduction toward the safety goal. The horizontal axis shows the magnitude of the consequences frequency of occurrences. The green area shows that the system is able to meet its safety object. This means that no countermeasures are required in this green area. On the other hand, the orange area shows that the safety goal would not be met. It means that countermeasures are required in this orange area. The gray area is called the AHFE zone. AHFE is short for as low as reasonably practicable. In the AHFE area, we need to discuss about the cost-benefit analysis, which one is the most desirable countermeasures, or including whether the countermeasures are really necessary or not. With using this with using such as analysis comparison between costs and benefits and the countermeasures are carried out. The concept of risk reduction measures is illustrated here. The risk curve is drawn on this coordinate. Frequency can be reduced by preventing its occurrences, such as common products, and the consequences can be reduced by reducing the hazard itself or by installing a mitigating system, which is installed from the start. And the middle area on this risk curve shows the overall balanced design and risk management through preventing and mitigation for the huge complex system. In fact, prevention and mitigation are illustrated on the right-hand side of this risk curve, which is shown as an event tree. So, if an initial event occurs, I mean a hazard appears, some kind of measures can be installed. And after that, if the measures is successful, the consequence can be reduced if the measure ends up failing. But given the probability of its happening, the frequency can also be reduced. Risk reduction measures for different systems are shown in this table. As you can see, there are many types of risk reduction measures, such as hazard reduction itself, occurrence frequency reduction by preventing measures, consequence reduction by mitigation system or mitigation operation. On the event of natural hazard, hazard reduction or occurrences frequency reduction are under out of human control. They cannot be controlled by human hands. So all we can do for them is just flood control or earthquake resistance, migration or evacuation. Huge complex systems adjusting poisoning by accidents, such as nuclear plant, power plant, and in this area, because the change of plant size into small one or attach intrinsic safety features are very difficult or essential on the design phase. It must be installed at the original or initial design phase. In addition, various safety logic can be reduced in the occurrence of frequency mitigation system. Consequence reduction can be achieved and when the migration evacuation is required. Consequence reduction can also be achieved. Lastly, I will explain about the relationship between human factors and human performance improvement. In the traditional human perspective, individual errors are reduced by measures to prevent the recurrences of individual events. Thus, human performance improvement activities add a risk perspective to the traditional human factor perspective. This is why the concept of risk management is at the forefront of human performance improvement. So, risk management is therefore about identifying risks in advance across the system and reducing them rationally based on priorities. We need to look at both the human characteristic and what the human capability is at its fullest. This is what human performance improvement is all about. The conclusion: there are 6 activities to reduce risks. Firstly, leveraging human performance tools during runtime. Second, cause analysis when the problem occurred. But most important thing for risk reduction is on the planning phase. The risk management activity appear on risk assessment by practical engineers at the field work planning, long-term issues created and understood by executives, risk analysis on the safety system, and maintenance activities on the usual system. The risk reduction measures are the key for the risk management in the plant, such as hazard reduction itself, occurrence frequency reduction by preventing measures, consequence reduction by installing a mitigation system, and consequence reduction by mitigating operation. The work was supported in part by the member of committee in the Japanese Nuclear Safety Institute to establish the concept of human improvement based on risk management in order to create the lecture course for plant engineers. Thank you very much.